Now it works. So for the third time, I'm Daniel. Thank you, and I'm going to talk about how we implemented support for Iceberg Puffin statistics for the Apache Impala query engine. And first, I'm going to talk about the background. So what is Impala and what is Iceberg? Though probably most of you know at least a bit about Iceberg. Then I'm going to talk about the Puffin file format in general. And then I'm going to talk about how we implemented Puffin stats in Impala. It's important to note that we can only read Puffin stats currently in Impala. We cannot write them. So first, let's see, what is Apache Impala? It is a distributed, massively parallel SQL database engine that was designed for speed from the beginning. Because of this, most of it's written in C++. This part we call the backend, and it's responsible for distributed query execution. We also use LLVM to make it even faster. But it's also got another part, which we call the front end, and that's written in Java, and that is responsible for query planning, optimization, and distributing tasks to the backend executors. So Impala supports various storage systems. Originally, it was designed for Hadoop, so HDFS, but now it supports also cloud storage and different storage engines like Kudu or HBase. We support different table formats. Originally, we had the Hive table format, but now we can also use Iceberg, read and write. And we support various file formats. Our favorite is Parquet. As for statistics, we rely traditionally on the HMS, so the Hive metastore. So we read our statistics from there and write them to that place. But now we can also read Puffin stats for Iceberg tables. This is what the architecture of Impala looks like. So at the bottom you can see the storage layer, that's not Impala. So the green parts they belong to Impala, the others are different services outside of Impala. At the top you can see the metadata layer. The most important part here is the Hive metastore, which is the catalog. We also have a component within Impala which we call the catalog, and that mostly acts as a cache between the HMS and the other parts of Impala. And in the execution layer we have two Impala roles, coordinators and executors. Now, what is Iceberg? So you probably know it's a table format for analytical data sets. And this is distinct from a file format because a table format is, it defines what actually constitutes a table. So it's how its data and metadata are stored. And of course, Iceberg also supports different file formats and different operations like insertion, deletion, updates, and it's good because it's done mostly in a transactional way, so we don't really need to be worried with data corruption. And there are various other things, but what's important for us is snapshots. So each time you modify an Iceberg table, you create a different snapshot, and it's possible to go back to previous snapshots and also to query previous snapshots without setting your pointer back permanently. Iceberg is a specification, but it's also a library. It's written in Java, and we use it also in Impala to interact with Iceberg tables. It's not required to use this library. We could create our own, but we didn't. This is the architecture of Iceberg. Most of it you've already seen in the previous presentation. So you see at the top you have a catalog, and yeah, there are various catalogs out there. This is actually only one thing that a catalog absolutely needs to be able to do, and that is changing a pointer atomically, because that points to a metadata file, a metadata JSON file, which in turn points to other metadata files and ultimately to data files. If we have Puffin statistics, they are also referenced from this metadata file. Now, what is Puffin? Puffin is a file format that stores two kinds of things. One of them is arbitrary data blobs, so it's binary data, and the other part is metadata that is needed to interpret these blobs, and this is in JSON format. Currently, there are 1.5 use cases for Puffin. The first one, the one that's relevant to this talk, is table level statistics, and the other one is Iceberg v3 delete vectors. But now I'm only going to talk about statistics. So Puffin statistics files can store one type of stat, and that is the number of distinct values. Um, it is useful in queries because it can be used to estimate the selectivity of predicates and joins, or to estimate the size of the result sets of aggregations. But if you actually want to keep an accurate count of NDV in a column, you need to actually store the values, which is ON, so it's most of the time it's prohibitively expensive. You don't want to use that much space. But fortunately, there are other possibilities. So if the stats don't need to be 100% accurate, then you can use probabilistic methods to estimate the number of distinct values. And in Puffin, the choice has fallen on Apache theta sketches. So you can decide how much space you'd like to use for it. You can decide at the beginning and have a fixed size array. Of course, if it's bigger, then it could be more accurate. And then later on, you don't need to grow this array or shrink it. There are mostly two things that you can do with these sketches. The one is insert a new value. So for example, if you insert new rows into your table, then you can update the sketch. The other thing is you can merge different sketches, which means that theoretically, if you've got a union of two columns in a query, then, and you have theta sketches for both of these columns, then you can merge these and get an estimate for the overall number of distinct values of the union. This is not something that we have in Impala currently. This is a theoretical possibility. Also, another thing it could be to calculate theta sketches for each partition separately, and then we don't need to calculate one for the whole table, but because we can merge these. Currently in Iceberg, in the Iceberg specification, we don't have this. We have sketches for whole columns of the table, but this could be a theoretical possibility. Actually, in Impala, we do something similar, but not with Iceberg Puffin. Then let's have a look at what kind of stats we already have in Iceberg. So in the metadata layer, we already have some values, or optionally like number of values, number of nulls, or min-max values. And they are usually used to, especially in min-max values, are used to prune files that we don't even need to read if we have a predicate in a query. On the other hand, Puffin stores table-level statistics, and it's NDV, which is different from the other stats we have. Puffin is good because it's a cross-engine standard. So if you've got a scenario where you've got different query engines that you'd like to use, all of them can use the same set of statistics. So you can write statistics with one engine and read it and update it with another. If you'd like to, it's also possible to include engine-specific information in there if you really need to. One of the best things with Puffin stats and Iceberg is that these stats are tied to snapshots. So you always know if your stats are up to date or stale. And even if they are stale, you can have information on whether they are still useful for you. So if it's only for the previous snapshot, but you know that the last commit was just a small modification, then these stats may still be useful. And as I've said, Puffin stats are referenced in the metadata files. So this is how engines can find them if they exist for a specific table. This is the overall structure of a Puffin file. So at the beginning, after some magic bytes, you have the blobs, the binary data, and at the end, you've got a footer. Now, the footer consists of multiple fields, but the most important is the footer payload, which is a JSON structure, where you have some optional key value pairs properties, and a list of blob metadata structs. And you have one blob metadata for each of the blobs in the file. Now, for example, offset and length in blob metadata help you identify the blobs in the file, so that's how we can find your sketches. Snapshot is, of course, the snapshot for which this sketch was calculated. And also, we have some optional properties here, which I'll talk about a bit later. So now let's turn to how we implemented reading Puffin stats in Impala. We mostly had 3 stages. The first stage was just starting up. At this stage, we only cared about current statistics. So if you have statistics, if you have Puffin stats for a column for the current snapshot, then we use it. If you only have it for some of the previous snapshots, then we just ignore it at this stage. This is pretty simple to implement, so it was a good start. I'd like to say also that in general, for a Puffin table, you can have several different Puffin files, and of course in each Puffin file you have data for different columns. Now, some challenges. What happens if you've got multiple NDV values or sketches for the same column at the same snapshot? So this is not something that should happen. I don't see a valid use case for that, but it's not prohibited by the standard. And for example, it could happen if you have engines computing stats concurrently. Now, I think it's very simple to deal with this situation because these stats are calculated for the same data because it's the same snapshot. And it should be the same algorithm because it's Apache Theta sketches. So we can simply just use the first one that we encounter and we can ignore the rest. We don't even check whether it's the same value or not. Now, a little bit more interesting question is what happens if we have both Puffin stats, so the Iceberg statistics, and HMS stats, so statistics that Impala used to use since its creation. So Puffin stats are tied to snapshots, so we know whether they are accurate or not accurate, but up to date or not. HMS stats are not aware of Iceberg snapshots, so we don't know. And at this stage, when we only care about the current snapshot for Puffin stats, the choice is easy. We always use the Puffin stats if they are present, because that's always up to date. And if not, then we fall back to HMS. Now let's look at the second stage. That was actually an optimization. As I've said previously, you can have a statistics section in the metadata file, and it doesn't only contain references to Puffin files as paths, but it also contains the metadata of the blobs. And some writers, like for example Trino, write the actual NDVs, the numbers, as a property. And in Impala, where right now we can't even update these statistics or can't even write them, we don't really need the sketches themselves if we only need to read the NDV. So it's much easier to read this value from the metadata. And in many cases, if all of these blobs that we are interested in have this property at the metadata level, we don't even need to open Puffin files, which is good because we can save some I/O. And then the final stage, or the current stage, because we still have some work to do, is when we also read Puffin stats from older snapshots. So as I said previously, older statistics may also be useful sometimes. And what we want to do is to select for each column the most recent Puffin stat blob that we have. And we can do this based on the metadata, so we don't need to open Puffin files just to decide what we want to read. One of the consequences is that we may end up with statistics from different snapshots for different columns, and for some use cases that may not be optimal. But on the other hand, we have, for each column, we have the most recent stats that is available in the system. Again, we have the question, what happens if we have both Puffin stats and HMS stats? And here it is a bit more intricate. Of course, we'd like to choose the more recent ones. And for Puffin stats, we have the snapshot, which also has a timestamp, so we are good there. But for HMS, we don't have snapshot information. We have a table property that we always set, this has existed from before. So we have this impala.lastComputeStatsTime table property that we set. This is also a timestamp when we calculate statistics for the HMS. And we could think that this is okay. So if the snapshot's timestamp is more recent than this table property, then we use the Puffin stats. Otherwise, we could use the HMS stats. That doesn't sound quite right. So Imagine a situation where we have originally a snapshot n, and there's an ongoing task that's producing snapshot n+1, for example, inserting data. Before this new snapshot is committed, we start computing HMS stats. Again, we don't need to worry about data corruption because it will be based on snapshot n, so no problem there. But we compute these stats based on snapshot n, but the timestamp belonging to this computation will be after the commit timestamp of snapshot n+1. And let's imagine that at the same time, but after committing snapshot n+1, we also, maybe another engine also starts computing Puffin stats. So those Puffin stats are calculated based on snapshot n+1, but the timestamp is more recent for the HMS stats. So the HMS stats appear to be more recent than the Puffin stats, but it's not correct. So what can we do? And the solution we've decided to go with is storing the Iceberg snapshots also when we calculate HMS stats. So that's something we can do. And if we have that, then we can simply compare snapshots to snapshots, and this means that we'll always be correct. Now, the current state of affairs in Impala is that we have this information, so we compute, so we can store the snapshot IDs for HMS stats as well, and we do that. But unfortunately, we haven't reached the point when we actually use this information, so that remains to be done in the future. And also there's another thing that we'd like to do in the future, and that is implementing support for writing and updating Puffin stats. So currently it's not possible in Impala, but we hope that we can make it possible soon. Thank you very much.